Morning and welcome to the Davies Use Case webinar being presented by UT Southwestern Medical Center on fitness and error prevention. This is a Davies Award-winning use case for the value of health IT. My name is and I'm the Manager of Quality and Patient Safety, and it's my pleasure to moderate this presentation. HIMSS mission is promoting the use of health IT to improve the quality of healthcare delivery. HIMSS advocates the integration of clinical decision support and best practice guidance, analyze progress, and IT-enabled patient safety tools for all healthcare organizations, community members as vehicles for improving patient outcomes. The HIMSS Nicholas E. Davies Award of Excellence is the pinnacle of the HIMSS Value Recognition Program. The Davies Award recognizes outstanding achievement of organizations from around the world who have utilized health information technology to improve patient outcomes and value. The Davies Award-winning use cases have been peer-reviewed to validate sustainable, improved patient and business outcomes resulting from health IT-enabled care delivery. So it's my pleasure to welcome our two speakers for today's webinar, Crystal Baldwin and Dr. Majid Bassett. And welcome to the call, and I will turn it over to you to briefly introduce yourselves, and then you can move on to your presentation. Welcome.
Hi, my name is Majid Bassett. I'm a cardiologist and assistant CMI, and I'm joined today with Crystal Baldwin, who's the Director of Health System Informatics and Resource Operations Quality. Before I pass it on to Crystal, I'll just do a brief introduction about this problem that we were trying to solve here. Clinical decision support and errors are quite significant in EHR systems. And this has been published quite extensively in the lay press as well in scientific journals. Here are just a few examples of how these errors have caused significant problems and how they've actually led to malpractice claims and the complexities associated with that. We've noticed that, as we have shown in our other presentations, if you've seen that these systems are inherently very, very complex. And if you combine that with our Agile methodology, which is our first case as part of the Davies submission, you actually increase and create a very high risk for errors in this presentation. Just to tell you a little bit about what UT Southwestern is, we're a large academic medical center based in Dallas. We're HIMSS Stage 7, a magnet institution. We have a little over 600 beds at our primary hospital and our secondary hospital on campus. We have 1,700 physicians and a lot of research areas. We do about 40,000 ED visits, about 8,000 inpatient surgeries, and we're partnered with Texas Health Resources. We're continually growing across the North Texas area with a West Campus expansion and a radiation oncology facility, as well as Moncrief and Fort Worth. And now I'd like to pass it on to Crystal Baldwin, who's our Director of HSIR Operations, to continue the story.
So here was our problem that we were experiencing. Whenever you look at a system, over time, errors accumulate. What usually happens is a user using the system notices something and reports. And when an analyst digs into the problem, sometimes they fix the single record, but ideally they recognize there are many records in the similar situation, and they correct all, resetting the bar to 0. But what happens is over time, the error rate accumulates. Institutional memory is only so good, and humans are only so infallible. The frequency of the error, it may have been suppressed, but what happens is typically over time, the error will repeat itself. This is an example of an error that was reported by our end users. And in this specific example, it represents a business rule to prevent billing errors, and we're going to show it in the form of an Agile user story. As a charge master coordinator, I need a test created to check the accuracy of the show on UB item on a hospital billing chargeable procedure record, and the HCPCS code is valid. The can be seen as part of the physician billing process. When a clinician performs a procedure, they put in their charges or transaction records, and the system maps these charges to the respective CPT and HCPCS code. What a claim file looks like in Epic when it's missing a CPT code. This is not introduced at the time the physician adds their charges or when claims go out. Rather, the root cause of this error was an incorrect built procedure record. Story. When ChargeMaster staff are building their procedure records, this Show on UB checkbox must be checked. And also, the code and the code type must not conflict. What analysis at the time the problem was reported was 118 procedure records were in error. Our analysts corrected all these procedures, but what happened is the issue resurfaced in October, and what we learned through our analysis was there were new ChargeMaster analysts that had recently come on board, and these new analysts were responsible for creating these procedure records, and they started doing so without checking that UB box. When a claim is processed with an error, one of three outcomes may occur. The payment is reduced, an error is caught prior to the claim being sent, or a claim is denied. The last two result in the claim going into an edit queue requiring manual work by our billing teams, and this is very costly. We've estimated it takes about 20 minutes per transaction to correct one of these records. Before our automated testing, when you take the initial 118 procedure records in error, we discovered that 98 claim transactions were impacted. The expected reimbursement per transaction was over $5,500, and our patients were charged over $137. Later in this presentation, Dr. Bassett is going to show you the expected reimbursement and self-pay once this particular business rule was monitored via our automated testing framework. So organizations experience these types of issues, and referencing the Swiss cheese model, what most people do is they say their error rate is too high. We have too many gaps in our system, and they start to add extra layers around this problem. But typically, even the error continues to repeat itself because the system is still fallible. As people make changes, they patch, and institutional memory goes away. The issue has not been systematically solved. Quote, I want to read to you. I conclude that though the individual physician is not perfectible, the system of care is, and that the computer will play a major part in the perfection of future care systems. This was by Clem McDonald in the New England Journal of Medicine in 1976. So we are still aspiring to achieve goals thought of over 40 years ago. So, for example, we've realized if we were able to rerun the initial analysis on a regular basis, we would be able to find this error and fix before users reported. Became early detection. We believe the quicker we find, the less costly. We also wanted no repeat failures. If you report a single error, we want to create a process where we'll be able to detect within hours and correct before users notice or before it has downstream negative implications. We also wanted it to be automated. We don't believe throwing FTEs at it is a sustainable solution. We wanted reduced time to resolution, and we wanted it to be trackable so that we know where the problem is. The result, we want a high reliability of our systems and data. Implementation and governance. Types of automated testing. The first one is reactive. For reactive, an automated test is created because an error in our operational system has been reported by our customers. The second testing we're doing is preventative, and preventative typically starts out as a request from our internal application analysts. During development or testing, our analysts may recognize a high-risk function in the system that upon failure would result in a significant negative outcome. In this case, we'll proactively create an automated test. automated testing is called FitNesse. So let me give you some vocabulary so we can all speak the same language. FitNesse for integrated testing. And FitNesse is an HTML wiki-based open source front end to Fit. And we use this tool in a unique way to guarantee business rules in our system. And we told you about a failure story that came in through ServiceNow. And it gets converted into a fit table or truth table. This truth table, think of this in terms of if this, then this. And then it goes into the fit system. So when you're beige represents things that we actually had to build. And the green represents capabilities provided by the fit framework. Our test case. Now let me tell you about this custom fixture. The fixture is what allows us to ask the system under test, what do you believe to be true? And for this, we use dbFit. This whole system allows us to test one assertion, the expected outcome, which is represented in our fit table, against the actual outcome, which is represented in the system under test. Is if the expected output equals the actual output, the test will return as green, and if it fails, it's going to return as red. This is what allows us to connect to multiple systems. If you look at the FitNesse server, it's connected to dbFit and then the various SQL servers in our case. Most of our tests to date are run against Clarity, which is the epic relational representation of the Chronicles database. But we also connect through our data warehouse to several sources, many of them real-time. We can now calculate our time to detection. So our actual fit tests run very quickly, probably not even 5 minutes. And most of our tests today run against Clarity, and Clarity is updated every 24 hours. We run our tests first thing in the morning, so we've estimated our time to detection to be about 28 hours. We think this is pretty good, but we're actually working towards real-time testing using the KV SQL and Epic Chronicles, but we're not quite there yet. So let me get this started. We see a situation where an error has been reported to us, and we want to react to that. So we develop the failure story using our agile methodology, and it goes to the FIT committee for review. It's time to an analyst to do a deep dive into the data. And from there, we build and test the assertion, we correct all the records, and we add it to our regression test suite. Because of early detection of errors and preventing future issues, our analysts actually began requesting automated tests proactively. So we've built numerous preventative tests and put into our regression test suite. Many of these tests have never failed, and hopefully they never will. However, if they do, we can guarantee that we'll be able to detect quickly and hopefully resolve before our users identify. Information is going into our ServiceNow ticketing system so that we can track and report. We run our FitNesse regression test suite daily. And like I said, FitNesse will provide this dashboard that you're seeing, and if the tests pass, they're green. But when they fail, FitNesse is going to show them in red. And when an error is detected, it's looked at by one of our analysts, and it's reported in our ServiceNow tracking system to be assigned to an analyst that can resolve the issue. And then, like I said, all of this information is tracked in ServiceNow so that we can see trending by test and know exactly how many times these tests are failing over time. Around us is we are under the Enterprise Data Warehouse Steering Committee, which feeds the Business Rules Work Group, and FitNesse fits under that. Our committee is made up of myself and our CMIO, and then we have senior analysts from each of our major application teams. So we have a broad multidisciplinary representation. and he's going to talk you through our results.
Thank you very much, Crystal. So as we've developed these tests over time, we've accumulated over 130 tests that are run in our automated suite, and this number is growing quite quickly, actually, and will probably grow more as we get more and more exposure to this framework. As we showed you with the charge analysis, I'm going to come back to the story and give you some results, that we had these additional failures, and we wanted to show you a little bit more about what impact these failures had in the system. So if you look at the initial failure and we looked at the numbers before the test, we showed you that total per transaction reimbursement was around $5,600. But after we fixed the system, we actually got paid a little bit more, about 12% more. What was even more remarkable to us, we were able to reduce the self-pay component of it quite significantly. Now, these are relatively small numbers in the transaction domain, but they show that this type of testing can have a significant impact on financial situations. And when you scale these to larger and larger numbers, larger and larger institutions, the numbers can become quite astronomical. Let me switch direction and tell you a really interesting case that we have in our system. And I'm going to come back and use an agile user story to describe this. As an anesthesiologist, I need a FitNesse test to track the physical location of the tangent device and DIM for each anesthesia cart in the OR. Each tangent device is programmed to stay together with a specific DIM, and if separated, vitals from one patient could flow to a different patient's chart in Epic. Now, this is a complex story, and I'm going to walk you through it. These are the anesthesia carts that are in our system. They're used to manage vitals of sedated patients, and they do a very important task. But if you look at the back of this cart, there are a lot of cables and a lot of devices. And people who are familiar with the clinical domain will notice that in most carts, as well as in most rooms and ICUs, these devices are interchangeable. If your blood pressure cuff isn't working, you can disconnect it and connect another one. If your infusion pump isn't working, you can disconnect it and connect another one without any consequence. Well, that is except for one device. In order to get data out of these systems, we need to connect their serial data port data into our EHR. To do that, we use this little tan device in the back, which is a data interconnect module, and basically takes that serial connection on the left side and translates it to Ether connection on the right side. Well, that serial connection doesn't send a little important bit of information. It doesn't say which data card are you connected to, which anesthesia card are you connected to, so the device itself knows that information. Well, here you're getting ready to do a complex OR case in room 1, and you're booting up your computer, and you know what? It doesn't connect. So someone to say, well, everything on this card is interchangeable. We're not using room 2. Why don't we get the DIM from room 2 and connect it to the card? Well, the room 2 anesthesia card and the room 2 DIM is coded in our system. So what ends up happening is the data then gets routed incorrectly, either to the wrong patient charts or could be lost entirely, and we want to avoid that. So how do we solve this problem? This is not this data is configured wrong problem. This is a physical location problem. And for those of you who are really observant, notice that there is this connection is there, but these devices have this Centrac Asset Tag Tracker Mini. And what this is an RFID-based tracker that's located both on the DIM as well as on the anesthesia card itself. It's primarily used to make sure you know exactly where your expensive assets are at all time, and every few seconds, very frequently, it pings the central database saying, hey, I'm physically located right here. Well, what we can do is we can actually point FitNesse to this database as well, the Centani database. And what this FitNesse test does is the correct DIM attached to the correct cart. And if that gets decoupled, we can send off an alert very quickly before any patient data is sent to the wrong place. And currently, this is a pseudo real-time process that we run every 15 minutes, and we're moving very rapidly to make that real-time without having performance impact on our systems. Coming back to the overall framework, through our various tests, we've identified over 14,000 errors and corrected them all. And after most of these were identified in the initial phase when we corrected all the initial records, and over time we've actually identified very few new ones. So return on investment. Well, if you look at just meaningful use, you see that compliance for meaningful use is an enormous hurdle. It's very hard to do. And if you look at it, we've highlighted 5 cases here. Providers with that MPI but having ordering authority capabilities, and that is the trend of errors over time. Meaningful use electronic prescribing flag set to yes. SCR provider to license type mismatch, meaning physicians are not matched to the provider type. Primary scheduling department for MU providers, and active provider inactive using MyChart setting. So you have direct patient billing. And you can see we actually set up this test before there was an error. This was a preventative test, but we did have some identified errors later on that were caused by a batch upload. But we were able to identify and fix those before they had any impact. And we're talking, numbers that are quite significant. We're talking hundreds of thousands of dollars, and we're only looking at a few eligible physicians that failed e-prescribing. When you consider the totality of the test, it could, the numbers become very large. So if you didn't have FitNesse and wanted to try to do this manually, well, if you did only monthly tests, it's only a few $1,000s. But as you scale the frequency, this numbers grow very large. And by the time you get to daily testing, the FTEs, the numbers that you need for employees, starts getting into the hundreds of thousands. So things about additional uses for our automated testing strategy. Crystal explained to you really well the reactive fit testing as well as the preventative fit testing, but I wanted to extend that to test-driven development as well as predictive fit testing. We use this framework to do test-driven development and synergy, which are agile development methodology. And in this, we actually develop the test first. And as the test has no development behind it, no code that was to execute the process properly, the test will fail. But as we do the build for this, now we get feedback from the test saying whether the build is correct, and when the test passes, we know that we've built it correctly. And then we repeat the cycle. And as we move this process into production, the test and the build go together. And this is one example of that using our CDS framework for chronic kidney disease. When we first build a test and there's no BPA built for it, the whole system fails. But as we built it, through the building process, we were able to identify errors. And in this case, renal was included instead of nephrology. And when we correct that, we see that the test is appropriate. And now this test, through time, will maintain the correctness of this build. The other area that we use is for clinical decision support monitoring. The 2 types of failures are really overexpression, meaning the clinical decision support alert is shown when it's not supposed to, and underexpression, where the CDS is shown when it is not shown when it is supposed to. This is a false negative, and this is quite dangerous because we've noticed that clinicians start using these clinical decision support alerts quite frequently and are dependent on them. And when they don't show up, there's an assumption that it wasn't needed, and that can be very dangerous. This is our framework for using automated detection using machine learning to identify where these failures could have potentially occurred. And we're working on this currently to advance our identification of errors before even a user complains about it initially. So we use FitNesse and the framework to create a high reliability system to identify errors and prevent them from happening again in a reasonable amount of time. Our detection can be used to extend to any database architecture, even in this case a tangent physical location device, to continue to monitor, identify, and reduce these errors. We're able to reduce the time of detection now to around 24 hours and 15 minutes if you have real-time updates, and we're hoping to go to true real-time as we get more sophisticated systems in place. This all fits into our overall framework of our PDSA cycle to modeling, our agile development, and our data warehouse, which are our other 2 cases. And then we use this to fit into the error detection and the continued monitoring so we know when we need to act again. We want to thank you very much for listening to this presentation, and I hope you'll reach out to us if you're interested in finding out more or looking to collaborate. Thank you very much.
Well, Dr. Bassett and Crystal for that great presentation. I'd like to tell folks where to find more Davies recording and this recording in particular. That information could be found on the HIMSS Davies website at HIMSS.org/Davies, and that's how to apply for Davies Award and more Davies use case webinars and recording. So once again, thank you for joining us today and presenting.